Hello, this is Dr. Patrick Hanley at Hanley Innovations. Today I'm doing a quick run through of how to analyze an aircraft using Stallion 3D. Stallion 3D is a compressible Navier-Stokes solver using a turbulence model that can get lift, drag, moments, a number of other parameters on an ordinary Windows laptop or computer. So to start, let's import an aircraft. And the way you do that, you click the design menu followed by import edit STL file. Now Stallion 3D can read either an ASCII or binary STL file. And this file was created by OpenVSP. The geometry, this particular geometry was downloaded from OpenVSP Airshare. So now we have the file. The next thing to do in Stallion 3D is to make sure we have the correct dimensions. STL files do not come with dimensions, so we have to scale it. We have to scale the file to the correct dimensions. Once we have that, click OK. Then we can click the design menu and take a look at how the wireframe is going to appear in Stallion 3D. So we're all set. The next thing we can do is to set up the CFD solver. The CFD solver in Stallion 3D does automatic grid generation, both for the surface mesh and the volume mesh. So to start, we set up a small grid about 500,000 cells. Stallion 3D has options for 2 million or even a little bit more than 2 million cells. Next thing we need to do is to set the grid shape. And here we have the Cartesian grid. And the outer boundary shape is going to have 4 cells in X, 2 in Y, and 4 in Z. And it's going to have a dimension of, that is the longest side length is going to be 72 meters for this particular aircraft. That's all we need to do to set up the grid generation. And the default solver is Navier-Stokes. So we do not have to specify that. It's a Navier-Stokes second order solver. And it has a wall function based on the K epsilon turbulence model. The next thing we do is then to click the CFD solver again, then click the menu to generate the grid and solve the flow. For this particular size grid, good convergence is obtained probably after about 3,000 iterations, and that takes about 2 to 3 hours on a laptop computer, just an ordinary laptop computer. So when we look at this solution, we take a look at the View 3D from the visualization menu, and we see we have the 3D solution. And it has, we have seen the computational mesh that was generated, and we're looking at the aircraft that we obtained from the OpenVSP hangar. So we have the solution, we have the pressure distribution on the surface of the aircraft. We could also look at the aerodynamics data, so we can get the lift coefficient, drag, lift to drag ratio for this particular speed and angle of attack, and a number of different parameters that could be or might be of interest, such as pitching moment, roll coefficients, and so forth. In addition to that, we can look at the aerodynamic forces based on the speed and based on altitude and the size of the aircraft. So here we have, for example, the lift force is 1,691 pounds. So that's a quick overview of Stallion 3D, and more information can be found at handleinnovations.com. Thank you for watching.